Good day to all of you. So we're already in chapter 15, which is all about file system internals. So to know more about this topic, so let's start our lesson. So again, chapter 15 is all about file system internals. So the contents of chapter 15 are file systems, file system mounting, partitions and mounting, file sharing, virtual file systems, remote file systems, consistency semantics, and NFS or network file system. So the objectives for this chapter are delve into the details of file systems and their implementation, explore booting and file sharing, describe remote file systems using NFS as an example. So again, we've already actually discussed this in the previous chapters, but then again, so file system, so general purpose computers can have multiple storage devices. So these devices can be sliced into partitions which hold volumes, and then volumes can span multiple partitions, and then each volume usually formatted into a file system, and the number of file system varies, typically dozens available to choose from, as we have already seen in the previous chapters. So this is the typical storage device organization. Actually, this is the most common for Windows. We have a disk or hard disk drive, and then you divide your hard disk drive into two partitions, and these two partitions also corresponds to the number of volumes. So for example, for partition A, this is where your Windows is installed, and then for partition B is where your data, your files are stored. So this is a very good, a convenient setup. For example, if your Windows file is corrupted or there is a problem with regards to your operating system, your files will not be affected. So that is the main advantage of having partitions, one or more partitions in your storage device. Unlike, for example, if your physical drive only has one partition, and what if your the Windows installation or Windows operating system has become corrupted, or you cannot access the drive, there is a possibility that also that the files that is saved in that same partition will not be recovered. So again, so as you computer enthusiasts and of course computer students and also studying computers, so the advantage is that, or it is better to have one or more partitions for your physical storage device. So this is another one on the right, but of course it's not a common setup for Windows since we are used to Windows operating system. So for this one, we have storage device 2 and 3, and then corresponds also to partition C and partition D. But this partitions is just composed of, it's only for one volume. So this is an unusual setup compared for the left side, which is the common setup in Windows. So it means that your hard disk drive is divided into partitions or divisions. So we have the example mount points and file systems for Solaris. So those listed here are the types of file systems that is found in Solaris. So UFS, DevFS. So it depends upon the application or process. Okay, next is we have partitions and mounting. So partition can be a volume containing a file system. So file system, it means it's cooked, meaning for example, for a house, so if you have a file system, there is a corresponding space for each of the parts of the house, or raw. So raw means it's just a space, so just a sequence of blocks with no file system. So boot block can point to boot volume or bootloader set of blocks that contain enough code to know how to load the kernel from the file system, or a boot management program for multi-OS booting. So example of a boot management program for multi-OS booting is GRUB, which is found in Linux. So next is we have the root partition. It contains the OS. Other partitions can hold other OSs, other file systems, or be raw. So root partition is mounted at boot time because of course it is where the operating system resides. And then other partitions can mount automatically or manually on mount points location at which they can be accessed. Actually, example for Windows, and I think in other operating systems such as Linux and Mac OS. So most of the hard disk drives that is already installed or already set up in the computer, it is automatically mounted. The user does not need to manually mount the devices, the storage devices. And the next at mount time, file system is consistently checked. Okay, is by means of checking, is all metadata correct? So if it's not correct, fix it and try again. If yes, add to mount table and allow access. Okay, so we've already seen this example in the previous chapter for file systems and mounting. So for letter A, so a Unix-like file system directory tree. So it is mounted. So there is the root directory or root partition, and then letter B is an unmounted file system because there is no root here. And then after mounting B into the existing directory tree, so it's already mounted for this example, which is what mounted is we have here in letter B. Okay, next is we have file sharing. So allows multiple users or systems access to the same files. Of course, that's the goal of file sharing. And then permissions or protection must be implemented, and it should be accurate. So most systems provide concepts of owner and then group member, so administrator, then guest, and then must have a way to apply this between systems. So we have virtual file systems or VFS on Unix provide an object-oriented way of implementing file systems. So VFS allows the same system call interface or the API, application programming interface, to be used for different types of file systems. This VFS separates file system generic operations from implementation details, and then implementations can be one of many file system types or network file system. And then this also implements vNodes or virtual nodes, which holds which hold inodes or network file details. And then this also VFS, this also dispatches operation to appropriate file system implementation routines. So the API is to the VFS interface rather than any specific type of system. So this is the setup for VFS. So we have a file system interface, and then we also have the virtual file system interface, and then this is connected with local file system type 1, type 2, and then we also have a remote file system. And then of course this local file system, these are used by the disks. Next is we have the virtual file system implementation. So for example, Linux has 4 object types. So we have inode. So inode is a per file data structure holding most of the metadata of the file. So for inode, this is the file control block or FCB in most Unix file systems. And then of course we have also the file. So the smallest logical storage unit, a collection of related information defined by its creator. And then next is we have the super block. So the super block is the VFS representation of the entire file system. And then we have DENCHI or DNCHI, the VFS representation of a directory. So that's the 4 objects of Linux, object types. Then VFS defines set of operations on the objects that must be implemented. So every object has a pointer to a function table, and then the function table has addresses of routines to implement that function on that object. So for example, so for this function, so int open, of course, open a file. Int close an already open file. And then sst read from a file. And then ssist rather, read. And then ssist write, which is a function to write to a file. And in mmap or memory map a file. So next is we have remote file system. So these are sharing of files across a network. So first method involved manually sharing a file. Programs like FTP. So FTP is file transfer protocol. And then the second method uses a distributed file system or DFS. So by means of DFS, so remote directories visible from local machine. And then we also have the third method, which is use World Wide Web. So the third method is a bit of a revision to first method, and then use browser to locate file or files and download or upload. So anonymous access doesn't require authentication. As you can already see, with using World Wide Web or in the internet, you can download files as long of course the server allows it to be downloaded, and of course you can also upload files. So that is the third method for remote file systems. So next is we have the client-server model. So sharing between a server. So the server is the one that providing access to a file system via a network protocol, and a client. So the client is the one that using the protocol to access the remote file system. Identifying each other via network ID can be spoofed. Later on, we'll be having this spoofed in the later chapters, which deals with chapter 16, all about security. And then encryption can be performance expensive. So we will already also study what is encryption in the next chapter. So we have NFS or the network file system as an example. So user auth info or the authorization information on clients and servers must match. So user IDs, for example. And then remote file system is mounted. File operations sent on behalf of user across network to server. And then server checks permissions, file handle returned, and then handle used for reads and writes until file is closed. So next is we have the distributed distributed information systems or DIS. So as known as the distributed naming services provide unified access to information needed for remote computing. So next is we have the domain name system or the DNS. It also provides host name to network address translations for the internet. So for domain name system, for example, facebook.com. Of course, facebook.com has their servers and it has a network address. So it's very convenient to have the DNS because if there is no DNS, it's very hard or memorize to memorize all of the websites that exist. For example, what if Facebook is example is the IP address is or the URL is 192.168.64.5 for instance. So it's very difficult to memorize if there is no domain name system. There is no unique name for that. So now that it's very good that it was implemented so that we know facebook.com. So we have yahoo.com and any other websites. It's because of the domain name system. You don't need to know the particular server or their particular IP address in which these sites are uploaded and running. And then we also have others like Network Information Service or NIS, provide username, password, user ID, and group information. And then we also have the Microsoft's Common Internet File System or CIFS, which is the network info is used with user authorization to create network logins that server uses to allow and to deny access. And then we have the Active Directory. So Active Directory, this is the Windows Distributed Information System, which is the Windows implementation of LDAP or the Lightweight Directory Access Protocol. So we have Kerberos derived network authentication protocol. So Kerberos, it is a network authentication protocol that is invented at MIT that forms the basis for the Microsoft Network Authentication Protocol. So next is we have industry moving toward LDAP or the Lightweight Directory Access Protocol, a secure distributed naming mechanism. So this LDAP, this is of course, again, it is a secure distributed naming mechanism used throughout the computer industry. So this is like the standard for secure distributed naming mechanism. Okay, next is we have consistency semantics. It is an important criteria for evaluating file sharing file systems. So specify how multiple users are to access shared simultaneously. So when modifications of data will be observed by the other users. So for example, if someone or this or the owner of the file is editing the file, can the readers view that or not? And then directly related to process synchronization algorithms, but atomicity across a network has high overhead. So we already see the Andrew file system later. So the series of accesses between file open and closed are called file session. So for Unix semantics, so writes to open file immediately visible to others with file open. So that's their consistency semantics for Unix. So if you're going to modify the file, it will be visible to other um, viewers with that file. And then one mode of sharing allows user to share pointer to current IO location in file. So it single physical image access exclusively, contention causes process delays. So how about the session semantics of Andrew file system, or another is the open Andrew file system? So writes to open file not visible during session, only at close. So it means while the author of the file, for example, is editing its file, so the changes will not be visible with other viewers who has opened that particular file. The changes will only be implemented in all the copies if the file is already closed. And then can be several copies, each changed independently. Okay, next is we have the Sun Network File System, or the SNFS. So an implementation specification of a software system for accessing remote files across LANs or WANs. So the implementation, originally part of Sun OS operating system, now an industry standard, and it's also very common since it is the industry standard. So can use unreliable data protocol such as the user datagram protocol or the internet protocol or the TCP/IP or the transmission control protocol over internet protocol over Ethernet or other network. So continuation with the discussion. So interconnected workstation viewed as a set of independent machines with independent file systems, which allow sharing among these file systems in a transparent manner. And then a remote directory is mounted over a local file system directory. And then the mounted directory looks like an integral subtree of the local file system, replacing the subtree descending from the local directory. And then specification of the remote directory for the mount operation is non-transparent. The host name of the remote directory has to be provided. And then the files in the remote directory can then be accessed in a transparent manner. Subject to access rights accreditation, potentially any file system or directory within the file system can be mounted remotely on top of any local directory. So NFS is designed to operate in a heterogeneous environment of different machines, operating systems, and network architectures. And then the NFS specifications is independent of this media. So it means disregarding if your operating system is Windows, Linux, or Mac OS, and though you're using smartphones, and then of course you're using Android operating system. So for NFS, it does not matter to it. So this independence is achieved through the use of RPC, or remote procedure call primitives, built on top of an external data representation, or the XDR protocol, used between two implementation independent interfaces. So the NFS specification distinguishes between the services provided by a mount mechanism and the actual remote file access services. So we have three independent file systems. So we have, for example, U for S1 and S2. And then you're going to mount S1 to U. So as you can see, from the previous example, we have user and local. What happens here is that the shared of S1 will be the local of U, as you can see already here in our the pattern for local is the checkered one, which is the shared directory of S1. And then of course, since it's already shared, so the directory one, which is also located in S1, can be accessed in U. Okay, and then next is what in letter B. So that is the mounts. What is cascading mounts? So what if S2 is mounted in U? So while there is also S1. So still the local is still the directory shared by S1, but as you can already see, since S2 is mounted also in U, in which S1 is already mounted, the directory 2 can be seen in the cascading mounts. So this is the directory of S3. So that is what we call the cascading mounts. Okay, next is we have the NFS Mount Protocol. So this protocol establishes initial logical connection between server and client. Then the mount operations includes name of remote directory to be mounted and the name of server machine storing it. And then mount request is mapped to corresponding RPC and forwarded to mount server running on server machine. And then export list, so this specifies local file systems that server exports for mounting, along with names of machines that are permitted to mount them. And then following a mount request that conforms to this export list, the server returns a file handle, a key for further accesses. And then this file handler is a file system identifier and an inode number to identify the mounted directory within the exported file system. And then the mount operation changes only the user's view and does not affect the server side. So continuing with NFS protocol. So the NFS protocol, this provides a set of remote procedure calls for remote file operations. The procedures support the following operations, such as searching for a file within a directory, reading a set of directory entries, manipulating links and directories, accessing file attributes, and reading and writing files. So NFS servers are stateless. So stateless means a protocol in which the state is not needed to be maintained for proper operation. So each request has to provide a full set of arguments. So NFS version 4 is newer, less used, and it's very different. And compared to NFS servers, they are stateful. And then modified data must be committed to the server's disk before results are returned to the client. So this lose advantages of caching. And then NFS protocol does not provide concurrency control mechanisms. Okay, next is we have the three major layers of NFS architecture. So Unix file system interface based on the open, read, write, and close calls and file descriptors. So virtual file system or the VFS layer distinguishes local files from remote ones, and local files are further distinguished according to their file system types. So the VFS activates file system specific operations to handle local requests according to their file system types and calls the NFS protocol procedures for remote requests. So for NFS service layer, so this is the bottom layer of the architecture, and then this also implements the NFS protocol. So this is the schematic view of the NFS architecture. For example, the client wants to access a file from the server, so we have the system calls interface and then the VFS interface, and then this VFS interface is connected to other types of file system, the Unix file system and the NFS client. Since again, for example, to show you how this is used, you are going to access a file or you're going to download a file from this disk from the server. So it will go to the NFS client, and then we have the RPC or the remote procedure call, or it also uses the external data representation, and then it will go to the network, and then going to the server side, it has a corresponding RPC or XDR, and then the NFS server, and then it will go to the VFS interface and the Unix file system, and then the disk, and of course the client requests for the copy of that file, so it will return to the same path. So disk, Unix file system, VFS interface, NFS server, RPC or XDR, and then network, and then corresponding RPC XDR of the client, then NFS client, and then the VFS interface, system calls interface, until the client already acquired the copy of the file from the disk of the server. Next is we have the NFS path name translation, performed by breaking the path into component names and performing a separate NFS lookup call for every pair of component name and directory vnode. To make lookup faster, a directory name lookup cache on the client's side holds the vnodes for remote directory names. So for NFS remote operations, so nearly one-to-one correspondence between regular Unix system calls and the NFS protocol RPCs, except for opening and closing files. And then the NFS adheres to the remote service paradigm, but employs buffering and caching techniques for the sake of performance. And then the file blocks cache, so it is when a file is opened, the kernel checks with the remote server whether to fetch or revalidate the cached attributes. And then these cached file blocks are used only if the corresponding cached attributes are up to date. And then we also have the file attribute cache. The attribute cache is updated whenever new attributes arrive from the server. And then clients do not free delayed write blocks until the server confirms that the data have been written to the disk. So this ends the discussion for chapter 15, the file system internals. So I hope that you've learned something. So most of the lessons here is based on Unix file system because they have the network file system. So I hope again, if you do have any questions, so please feel free to comment below. And please don't forget to subscribe to my YouTube channel. Again, thank you very much. Good day and happy learning.